A monomial is expressed as a product of prime numbers and variables with no variable having an exponent greater than 1. That's completely factored. So we factor the 20, and we get 2 times 2 times 5. X to the third was x times x times x. Y squared was y times y. This is the completely factored form. Okay. So 52. 2 times 26. 26 is 2 times 13. One of these is going to have to be negative because my 52 is negative. So I'm just going to put the negative out front. A squared is a times a, and b is just a b.
2 times 3 is 26.
13. Thank you. I said 13 and I wrote 3.
You played a trick on me.
I did, I'm sorry. $34 is 2 times 17. 17 is prime. So the completely factored form of this will be 2 times 17 times, okay, I've got x to the fourth, so there's 4 x's and 3 y's. It's not even.
But it's divisible by 5.
It's divisible by 5 because it ends in 5. So I'm going to do 5 times 63. And 63, to tell if number is divisible by 3, you add the digits. So 6 plus 3 is 9. 9 will divide by 3, so 63 would also divide by 3. Or you could do, if you pop it on your head, 7 times 9, however you want to do that. But I'm going to go ahead and go with the 3 on this, and that's 21. And 21 is 3 times 7. So I'm going to have 3 times 3 times 5 times 7, and it doesn't matter what order you put these in. Actually, I just like to put them in numerical order because it's prettier. 2 x's and 4 y's. And that's the completely factored form. So do you guys need me to go over the divisibility, so how you can tell what numbers divide by which?
Sure. Yeah, that would be helpful.
Okay. Okay. So divisibility. It means to divide evenly. Okay, so to divide by 2, the number needs to end in 0, 2, 4, 6, or 8. So in other words, it's even. All even numbers divide by 2. To divide by 3, you add up the digits. If the sum divides by 3, the original number divides by 3. So, for example,
Is that up to 9? It can be divided?
if it adds up to 9, if it adds up to 21, if it adds up to anything, that'll divide by 3. So, let's see if I did. Okay, big long number, right? And I want to know, will this divide by 3? Well, if I add them up, I get 7 plus 5 plus 4 plus 2 plus 1 plus 2. So that's 12, 16, 17, 18, 19, 20, 21. 21 divides by 3.
So you know that.
So this whole number will divide by 3. And if I actually do the division, it's so 754,212 divided by 3 is 251,404. So it will divide evenly. So it's just a quick check. Rather than try to divide the whole number and see, you add the digits, and if the digits will divide by 3, then the whole number will divide by 3. To divide by 5, you're going to end in 0 or 5. to divide by, oh, I forgot to divide by 4. To divide by 4, the last 2 digits have to divide by 4. So for example, if you have a number that's like, all I have to do is I look at these last 2 digits. 28 divides by 4, so this whole thing will divide by 4. To divide by 10, you end in 0. To divide by 6, you're even, and you divide by 3. So if both of these rules are true, then it'll divide by 6 as well. There's a rule for 7, but it's not very useful. Same thing for 8. If it'll divide by 8, it divides by 4. It's more useful usually to divide by the smaller number anyway. And 9 is the same rule as 3, except if the sum will divide by 9, then the whole thing will divide by 9. So this number would not divide by 9, because 21 does not divide by 9.
So it's the same as 3?
Yeah, same as 3, but the sum of the digits adds up to 9. Or not adds up to 9. But they divide by 9. Greatest common factor is the largest number that is a factor, and by factor I mean divides into two or more numbers. Okay, so we're looking for the number that will go into evenly, 2 or more numbers. So my favorite way to find GCF is factor trees.
Divides, what's the first?
Into. Sorry, that's not very pretty. I fix it.
So it's a factor of 2 or more numbers?
So it's the factor, it's the largest factor that will go into both numbers.
Yeah.
So like if I look at 12 and 18, 2 is the greatest common factor. 2 will go into both of them, but it's not the largest. Sometimes it's easy to see it and sometimes it's not. That's why I'm going to teach you the factor tree method. So what we do is I'm going to factor 12 and I'm going to factor 18. Okay. And then I look at all of the numbers that match between the two. So I have a 2 that matches and I have a 3 that matches.
Do they go away?
No, I write those down.
Not
These are the
really.
matching pairs. So we look, find the matches,
Matches.
and then we write those down. Okay, so the greatest common factor between 12 and 18 is going to be 6. This is the GCF between 12 and 18.
So the 2 matching numbers that you like
Pull out, basically.
put together,
Yeah.
even though there was like a 6 up there already.
Right, but you see I didn't have a 6 here originally. But
Just the
the matching ones, yeah.
matches.
So now I found the matches on the number portions, and then I'm going to take the smallest amount.
What if,
Oh,
what if
sorry,
you had
not
done
small.
3 and 6? Would it have been a match right away?
Yeah, you could have done that right away. Take the,
Would it have been 6, so would it have been?
Small.
Actually, no, yeah, it would have been the A6 and another number.
okay, so I've got the number, the 6, that's for the numerical part. Now I need the variable part. Okay, I have an A squared and an A. A is smaller. So I'm going to take the A. So I've got 6A. And then I have a b squared and a b to the third. B is smaller.
So you go to
Or b
16.
squared, sorry. So I'm going to take b squared. Okay, so a is smaller than a squared, so I can't take a squared because a squared won't fit into both. Only a will fit into both. And then I have b squared and b to the third. Well, b squared will fit into both, but b to the third won't fit inside of a b squared. Does that make
What about
sense?
C?
C doesn't match.
Hmm.
So it's only on the matching letters. So you take the smallest exponent version of the matching letters. So in this case, a was smaller than a squared, and b squared was smaller than b to the third, so that's where I got those. That's my GCF. What is the point? Okay, so I am a florist. I have 20 roses, I have 30 tulips, and I want to make bouquets. And I want them all to be the same, identical bouquets, because like it's Valentine's Day coming up, right? So I want to make identical Valentine's Day bouquets with these flowers. I don't want to have any flowers left over. So I need to figure out how many of each flower do I put in the bouquet.
How many bouquets does she want to make?
That's what I have to find out. What is the greatest number of identical bouquets? The greatest number of identical
Two
bouquets is
roses
going to
and
be
3
my
tulips.
GCF. So
That would be
actually
10
my
bouquets.
GCF
Wait,
is
the
not going to
greatest
be
number of identical bouquets, or is the greatest number of flowers in each bouquet?
Well, that would be like
greatest number of identical bouquets is the
that would
GCF.
be like 2 roses
So you
and
want
3
to have the least
tulips
amount of
each.
flowers each? Okay.
So I can make 10 bouquets,
Yeah, that was easy.
right? So the GCF is 10, so I can make 10 bouquets.
I've made bouquets before. I know how to
I
do
can't
that.
spell bouquets. So I make 10 bouquets, and each bouquet will have 2 roses and 3 tulips.
I said that right at the beginning. I've done that.
Okay, so I factored 60 and 15, and I got that my greatest common factor was 3 times 5, which is 3 times 5, which is 15. Okay, so there are going to be 15 beads on each bracelet.
Wouldn't it be $30 for the gemstone beads?
$7.50, right? Because I've got 60 divided by 15. That means I can make 4 bracelets, right?
But it's per bead.
15 beads times 0.5
Oh, per bracelet.
per.
Sorry.
Yeah, so $7.50 per bracelet. So she's got 15 beads on the bracelet. She's selling them for 50 cents per bead. So that'll be $7.50 for the gemstone bracelets. And then 15 times 0.25 gives me $3.75 for the glass bracelets. And if you wanted to find out how much money she'll make, sorry, we didn't finish it. I didn't finish it. I have to do $7.50 times 4, because that's how much she's going to make on the gemstone bracelets, right?
Yeah.
And I'm guessing plus the 375.
So 30 plus 375. So she's going to make 33.75.
Not bad.
I kind of skipped a step.
You don't.
Yeah. So we're going to be, it's basically factoring using the distributive property is basically backwards from what we've done. We've done the distributive property, right? We did
We've
3
only taken
times
apart the computer. Now
2x
we've
plus
done
4 gave me 6x plus 12, right? So I multiplied a 3 in.
that.
Well, the distributive property backwards
Is the completed
is I'm gonna
equation
take a
being charged
3
with the
out.
original? So go 3.
Well, no, the 3 is there. So basically what I've done is I divide each of these
By a number they have in common.
by the GCF. So 3 is,
So if you did like the factor.
oh, I picked a bad example
Again.
Oh.
because 6 my own head.
Yeah, I kind of knew you were trying to do something like that, so I'm like,
Okay,
yeah.
so I made a bad example because I ended up with 1. So let's do 2 times
8.
3x plus 5. This will work. So I get 6x plus 10. So then if I take 6x plus 10, the greatest common factor of 6
Is 2.
and 10 is 2. So I get 3x plus 5. And so what I'm doing is I'm dividing each of these
By their
by the greatest common factor. So we're doing the distributive property backwards. We're pulling out instead of multiplying in. Okay, when a polynomial is completely factored, we've found the GCF of all of the terms and we've pulled it out. We've divided each term by that and we bring it out to the outside of the parenthesis like this. I'm going to look for the GCF between 27 and 18. And then the y's, right? So this is 3 times 9. This is 2 times 9. And I could factor the 9 if I want to and then multiply it back together. Or I can stop there. So I've got matching
like
9s.
18y, or are you going to make 81y?
No. I've got the 9 and then 1y because there's 1y here and 2 y's there.
So you're not going to, oh yeah, okay, I see. Sorry.
27 divided by 9 is 3. See, that's what's left.
Okay.
And then I had 2 y's. I took 1 out.
So I'm guessing that
There's
would
1
be
left.
y plus 2, parentheses ending.
18 divided by 9 is 2. I had 1 y. I took 1 out, so it's done.
Looks simple.
So I found the GCF, which was 9y. And then I divided 27y squared and 18y by 9y. Would you like to GCF between 2, 8, and 4? 2, right? 2, 8, and 4 will all divide by 2. I have 2 A's, 1A, 1A, so I can only bring out 1A. 1B, 2 B's, 1B, so I can only bring out 1B. So that's going to be my GCF, right? If I divide -4 by a +2, I get -2. I had 2 A's, I took 1 away, so I have 1 left. If I divide -8 by 2, I have -4. I had 1A, I took 1A away. Oh, I forgot the B's. I meant I had 1B, I took it away, there's none left. Okay, so I had 1A, I took 1 away, so there's none left. I had 2 B's, I took 1 away, so there's 1 B left. And then if I divide 2 by 2, I get 1. And I took away both the A and the B, so it's just +1.
So you're taking the GCF and then you're dividing the numbers by it?
Yeah, dividing each of these individually, I divide by the GCF.
And the GCF was 2AB because
All right, factoring by grouping happens when you factor polynomials that have 4 or more terms and you put them into groups and then factor it. That's why it's called factoring by grouping, because you put things into groups and then you factor them. Now, you are required to have these 3 conditions. You have to have 4 or more terms. You cannot take a 3-term polynomial, trinomial, and factor it by grouping. Because you can't have like a group of 2 and then a group of 1. It has to be like the very minimal, it has to be 2 groups of 2 at the minimal. So there has to be at least 4 terms.
like if it's a thing of 4 altogether or 2 and 2.
Yeah, exactly. Now the terms have to have common factors that you can group them together based on. So we'll go over some examples and I'll show you what that means. But basically, if you have 4 terms that have nothing in common, you can't group them.
You can't do nothing.
Yeah, you can't do anything. Yeah.
Does the one 4-term thing apply like trinomial, monomial, all the combinations you can think of?
It has to be at least 4 in there. So it's not. It's got to be 4 or more. So you can't do trinomials. It has to be.
Wait, so 2 trinomials, or it just can't be a single?
So it has to be sort of like.
Just wanted to make it clear.
Sorry, that's not even factorable. Hold on.
Well, I mean, just the
3x
example of the monomial or polynomial.
Okay, something like this would be factorable. And so it has to have at least this many terms, at least 4. So we have at least 4 terms. They have to have factors that can be grouped together, like things that they have in common, like, okay, these two I could group together because they both have x's. These two I could group together, they both divide by 2. Or I could group these two together because they both have x's. Or I could group these two together because they both have 4's and y's. You know, like there's got to be some way I can put them together that they match. Does that make sense?
So 2 common factors, there has to be
Yeah,
more
so
than
you
4
have to be able to
common.
group them in pairs or in threes that have something in common that you could take out of both or all of them. And then once I'm done, there has to be 2 common factors that are identical or additive inverses of each other, and this will make sense in a second. So
But
basically,
yeah, it's the grouping part. like
the
you-
general form of grouping oops, sorry, that should be bx. ax plus bx plus ay plus by. Okay, so it's just this is just general, this is called the general form. And it's just to kind of show you what do I have in common? I have 2 groups, right? I can group ax and bx together. And I can group AY and BY together because these have X's in common and these have Y's in common.
I just made a short thing in my own.
Or I could have grouped it by AX and AY together because they both have A's.
Well, why group it at all?
You have to group it to factor it. Because there's not one thing I can factor out of all 4 of these. Do you see that? So
GCT, group common term.
I can, group common terms. So I can factor an X out of those.
And the other ones you can factor out
I
a
can
Y.
factor Y out of those. And then this part, the 2 common factors that are identical, that refers to this. This
So-
is the 3rd rule.
Oh, so in what you were referring to is when they're all together like that, you can't get like a single part of it.
Mm-mm.
So yeah, you can't like make an XY because the ones the AX and BX don't have a Y with them. So yeah, you'd have to group them to get rid of them
So basically what happens is I take this 4-term polynomial
and turn it into 2.
and I turn it into a
binomials.
product of binomials by factoring it. So when these 2 parentheses match, they factor out essentially, or you can think of it as I take this and make a new parenthesis. And that just covered up everything I just did. So, but we'll go over it with like, there is more than one way to group.
You don't say.
Now here, I have 4QR 82.
So like before QR. and
That's not
3Q
supposed to be
group.
82. That's supposed to be 8R.
Uh-oh.
I don't know what I did. This should be 8R. So that's
now
a
it's on top.
typo, so sorry. Okay, so 4QR and 8R have a Q or 4 and an R in common, right? And then 3Q plus 6 have 3 in common. Or I could have grouped the 4 and the 3 together because they had a Q in common. So, I mean, there's more than one way to group it. I'm going to just keep it the way it is because these already have
Well, if it
stuff in
was-
common.
If it was 82 though, you could then group 82 and 6 together and just.
Yeah, but then I couldn't, it wouldn't work because things
I
didn't
know, I'm
match,
just
yeah.
saying, but-
So this will be one group and this will be the second group. These are my 2 groups. Okay? Now I can take from this first group a 4 and an R, which will leave me with a Q and a 2. From my second group, I can take a 3, which will leave me with a Q and a 2. So now I've factored out the GCF from the 2 groups, right? The next step is that you have to make sure, do these match?
Yes.
Yes, they do.
They'll
Okay?
have to match?
They have to match. So these must match. If they didn't match, try rearranging things and seeing if you can group it differently and factor it. Make sure you factored it correctly because they have to match. Once they match, that's one parenthesis. And then these two items go together with whatever symbol that is to make the other parenthesis. So this becomes one parenthesis. And then the blue stuff out front becomes the second parenthesis.
So the two parentheses aren't adding, they're multiplying?
So I have the two groups. My first group, like I said, they have an M in common, so I can factor an M out. If I take an M away from an M, I'm left with a 1. Right, because M divided by M is 1. And if I take an M away from 5M, I'm left with a 5.
So I'm guessing that one would be -1.
This is supposed to be a 1. My typing apparently was very bad that day. Okay. Negative.
-1.
Yeah, so I have, that's not right. That's not supposed to be, that was supposed to be a 1 or an R. I was supposed to have an R here. That's what I typed off. Sorry. So change that to an R instead of a 1. That's where my typo was.
So the second one would
The
be.
M's still go together.
The M's are still good.
Yeah.
There's just supposed to be a little R in front of that M.
So for the second half, it would be a -1.
I can factor out a -1
to R and
plus 5.
plus 5.
Yeah, because I've got -R and -5, right? So if I take a -1 away, it leaves me with positive R, positive 5. And then these match. So I have one parenthesis is R plus 5, and the other parenthesis is M. Can't write, can't type. And -1. Okay, so why don't you guys try inverses? Okay, I have 2mk minus 12m plus 42 minus 7k. I can take a 2 and an m out of the first group, right? So if that gives me 2m times k minus 6. And I can take 7 out of the second group, which gives me 7 times 6 minus k. And k minus 6 and 6 minus k, they're almost the same.
They're just backwards.
But they're backwards and the signs are wrong, right? Because this is positive k, this is negative k. This is -6, positive 6. So when this happens, I
It's
have
like a mirror.
additive inverses.
It's a mirror effect.
So what I need to do is I need to take this 7 and make it negative. Okay, so I take that 7 and I make it negative, and now this will match that.
So it's you change it to where
Why
they're
are we
both the
changing
same.
it though?
Because it doesn't match.
It needs to match.
It has to be in the same order? It does match though.
No, it doesn't match. K minus 6 and 6 minus k are not the same thing.
Because they switch places both by position and positive and negative.
It's the signs, yeah, that are the problem. Yeah. Yeah, go ahead. So because they didn't match, but I mean, they almost matched, right? They were so close. If I take that positive 7 and I make it a negative 7, I can make it match. Does that make sense? And now they match, so I have 2m minus 7.
Wait, but why does making the 7 negative reverse the order?
Okay, it technically doesn't. Okay, so if I have 7 times 6 minus k, That's the same thing as negative 7 times negative 6 plus k.
Okay.
But then I just changed the order to make them look nicer. Just okay.
Wait, what? So it's the same thing?
Yeah, it's the same thing. I just changed the order to make it look prettier, to make it match. It's not okay. This and this are not the same. I mean, are the okay? Hold on. All right.
I think I get it. Not anymore.
Hold on. K minus 6 and 6 minus k are not the same. If you think about this with numbers, 10 minus 6 and 6 minus 10 are not the same.
Because the one on the left has an imaginary.
This
plus
is
sign.
4. This is negative 4.
K is essentially just a 1.
K is some number,
Right.
some unknown number, right? So k minus 6 and 6 minus k are not the same. So if I have 7, so I had 2m times k minus 6, right? Plus 7 times 6 minus k. These almost match, but they don't, because this is a positive k, this is a negative k. Negative 6, positive 6. So I want to make them match. So what I do is I make this negative 7. And by doing that, I pulled out a negative 1, which changes these signs. So this actually becomes negative 6 plus k.
So then you can just reverse
Which
it.
these two are the same, but they don't really look the same. So what I do is I just make it match.
So you can just
so
make
it's
this
prettier.
negative,
Yeah.
'cause it's the same thing.
Essentially all you're doing.
Yeah, that's exactly all you're doing. If these are the same numbers, but the signs are wrong,
Right.
pull a negative out.
Okay. That's a lot easier than having to write all the extra work and
So
get confused.
you can change the sign and you can flip it around.
Yes.
All right.
Yeah. So, and you don't have to flip it. I just flipped it so it looked pretty,
It would still be the same thing.
but it'll still be the same thing.
And that's the additive inverse.
That's additive inverse. Additive inverse is same numbers, different signs. So if we come back to this page and I do another example, like I have C minus 2 CD, I can pull a C out of that and I get 1 minus 2D. And 8D and negative 4, I can pull a 4 out of that and I get 2D minus 1. Yeah.
So the answer for the one that we just did is 2m minus 7 times
K minus 6, yeah. So here, do you see how I pulled the C out and you see how I pulled the 4 out? And same numbers, wrong signs.
Just
So I'm
change
going to
that
make
negative.
that 4 negative.
And then that will negative 1 will become positive.
Yeah, so I do 1 minus 2D. And so it matches now.
Got it.
And so this becomes C minus 4 times 1 minus 2D. You-
Can you go back?
Yeah, hold on. Let me pause that. If I have x and y equals 0, x times y equals 0, that means
1.
either x equals 0 or y equals 0. One of them has to be 0.
And
Right?
one of them's a 1.
Or both.
It's a lot of material to take in a day.
I know. So if I'm already factored and I have this times this equals 0, that means that 2D plus 6 equals 0, 3D minus 15 equals 0. So you're going to split.
D is 0. Split and set. Like divide and conquer.
So split and set each equal to 0 and then solve. Okay. So subtract 6 from both sides and I get 2D equals negative 6. Divide by 2 and I get D equals negative 3. Over here, add 15 to both sides. and I get 3D equals 15. Divide by 3, and I get D equals 5. So I had 2 parentheses, so I'm going to get 2 answers. 2 parentheses, 2 answers. Okay.
He got rid of it.
Sometimes they're not equal to 0 yet. So I had to make it equal to 0. So to make this equal to 0, I can subtract 3c from both sides.
Fine.
So I get c squared is equal, oh sorry,
Can we go back over this on Wednesday?
yeah.
Mother of mercy.
C squared minus 3c equals 0. Okay, so 3c minus c equals 0. I set it equal to 0, so now I have to factor it. Oops, I forgot to write that in there. I'm sorry. So step 1 is set equal to 0. Step 2 is factor. Step 3 is then split and solve.
Factor, split, and solve. Like divide and conquer.
What can I take out of both of these?
A C.
A c.
C.
Okay, so I have c times c minus 3 equals 0. So then I'm going to split it. C equals 0. C minus 3 equals 0.
Because C is 0.
Add
minus
3 to
just
both
makes it
sides.
0.
So
it'd be
c equals 3. So my answer on this one would be c equals 0 or 3.
Can we leave?
Already tells me that one of these has to equal 0.
So this is just trying to figure out which one equals 0.
No, this is trying to find out what n could equal to make this true. I'm trying to find the n that will make this true. So either 3n has to be 0 or n plus 2 has to be 0. So I set them both equal to 0. Well, 3n, that means n equals 0. And here if I subtract 2, that would be n equals negative 2. And what this tells me is both of these numbers, if I plug either of these numbers in, it will still be true. Because if I plug in 0, I get 0 times 0 plus 2. So 0 times 2 equals 0. That's true. If I plug in negative 2, I get negative 6 times 0 equals 0. So that's also true. So there's 2 possible solutions. We don't know which one is necessarily the intended one, so we say both. Here I'm going to factor 8b.
Both equal 0. 0 is going to always be an answer or false.
No, not always. Not always, because what if I have... So 0 won't always be an answer, because in this situation I have 2n plus 3 equals 0, and minus 5 equals 0. So if I subtract 3, 2n equals negative 3. So n on this one is 3/2, negative, or 5.
Cocaine.
So they don't always equal 0. It always equals 0 if you got something like this, though. Because that's 8b equals 0. Well, 8 times 0 is 0, so b has to be 0. Right? And then I have b minus 5 equals 0. So I add 5 to both sides, so b equals 5.